The next problem is number 7 in Chapter 3 in Garrett Biochemistry. And for this problem, we're supposed to draw all possible resonance structures for creatine phosphate and discuss their possible effects on resonance stabilization of the molecule. So you learned from organic chemistry how to draw resonance structures, and so I'm not going to draw each one out by hand, but just kind of go over this a little bit. And you know that the more resonance structures a molecule has, the more stable it is in general, because having resonance means that those electrons are more spread out, and so it lowers the overall energy of the molecule. So let's look at these resonance structures. So our top structure here, let's start with this top one. Okay, we've got this carboxylate group, this C. A carboxylate group is C double bond OO minus. Okay, and it has resonance because we've got 3 lone pairs on that oxygen. So let's see what's going on with this one. If one of those moves down, then the next, so this lone pair becomes a pi bond. This pi bond becomes a lone pair. Okay, so now then for this structure, we've got 3 lone pairs on the next oxygen. Okay, and so also, what else happened here? So that's all that happened going from here to here. All right. And let's see. So this pi bond moves here in this molecule, giving us this pi bond here. Okay. This oxygen a pi bond becomes up to be a lone pair here, and this lone pair becomes a pi bond. So we had 3 lone pairs around the oxygen. Now we have 2. Okay. So if this pi bond moves here instead of to the left, then we have a pi bond here to that nitrogen. So we just have a lot of different structures here that are possible. Let's see. So this going from here to here, the pi bond has moved from one oxygen to the other. Okay. So just different things like that. I don't think I could draw all of these resonance structures without having a list here, because there's just so many. I mean, you'd forget one, right? The phosphate can also demonstrate resonance. So we have the double bond between the phosphorus and this oxygen, and so we can take one of these lone pairs, make it a pi bond becomes a lone pair going this way. Okay, and we can do the same thing all the way around that oxygen, make all that phosphorus, making the different oxygens double bonded. Okay, so we've got this one double bonded, this one double bonded. I'm looking for one on the bottom now. I don't see that one. This one double bonded. Okay, here it's double bonded to this one. So either of these nitrogens can be positively charged. Okay. Let's see. Or we can have the nitrogen at the top positively charged. So all 3 of those can be positively charged. And we can move this carboxylate group, the oxygens, the pi bond between the different oxygens on that group as well. So all of those things can move around. So there are a lot of different resonance structures here, and that's going to lower the overall energy for that molecule and make it extremely stable.